Well, how are you doing? Okay, this video will be called or titled True Perspective. Um, there's a bit of an issue with perspective. I've spoken about this for years and it's starting to catch on what optical drop is and what real perspective is. Because uh, as as flat earthers, we've been handed our perspective for years. And real perspective has been claimed by our opposition. But the truth be told is our opposition are claiming real perspective as their perspective because they're handing us our perspective. Um, our perspective and real perspective are different, and globe perspective doesn't exist because it can't, because we're not on a globe. If it did exist, then what we see would be completely different from what we actually do see. Um, what we would see in the distance and how things are would be completely different. I'm going to use this photograph. You all know this photograph from some months ago. There's been a lot of debate about what happened around this. it, if we were on a globe, I'm just going to show. Should you get a little bit of annotation here? Right. So we're on a globe. These mountains will be down here, right? That's where the top of the mountains will be if we're on a globe, right? Um, I'm not going to go into again. I've gone through all this as to why the mountains are lower than the tower. It's another effect called visual occultation. I demonstrate it and show it. So that's there if anyone wants to see it. I show it in real world and everything as well, different from this and how it happens. So I'm not going to go into that. But I'm just saying, if we were on a globe, what we'd see is the top of the mountains down here, maybe even a bit lower, right? That's what we would see because that's where the mountains would have to be, top of the mountains. So during a debate I had with one of the people that was promoting this some months ago, one of the things that he asked me, because he didn't know about optical drop, he says, "Where is eye level in this photo?" Would he say that? What he said is, would he say that this over here is about the same height as the cameraman? So if you can see, I have the line down there. I'll make it a slightly different color. Might be easier to see if I make it yellow, right? So if he says if the line down here, would that be about the same height as the cameraman? Was that? He was kind of giving the cameraman about around 20 foot or something like that, or more maybe, I don't know. But he said, would I agree with that? And I went, yeah, that's fine. That would be about 20 foot, right? And he said his argument then was, then if we come over here, then on the mountain, right, back here on the mountains, especially he was talking about these mountains here, he had some kind of a made up diagram of what the mountains were, and he placed this eye line here that was about 20 foot up here on the mountains in a direct straight line, because basically whatever the diagram he had was, it just removed Blackpool. But the problem was he placed the eye line hundreds of feet up the mountains. Right? He said, how can that happen if we're on a flat plane, right? But what he was forgetting about is this is the center of the lens. So this is the photographer's eye line here. That's the actual photographer's eye line right there, where that yellow bar is. In the distance, that as something moves away, the further he's looking at something, that eye line will appear to drop and drop and drop. And at this point, it's at here. So from the ground up to this yellow bar here, let's bring it down slightly more. From the ground up to this yellow bar, so from the beach up to this yellow bar, that is the exact same height as from sea level up to this, up to here. I'm just going to get another, right here, right. They're actually the exact same height, right, same elevation, right. They're both the same elevation above sea level, those two. It's only perspective that gives the impression, because of angular size change with distance, and because he's looking across a horizontal plane and he's making an optical horizontal with it. So these two are actually the same. So the ground up to this yellow line here is the same distance as from the sea level up to this yellow line. The cameraman's center vision or center view. So both of them are the same elevation above sea level, right? Both those yellow lines. But due to this one here being 6 miles away, something like that, if I remember correctly, due to that being that far away, it appears to be way lower. And what would happen is due to the angle, so this is a very limited angle here. You see how limited this is getting from, I'm just going to get another one, make it a different color, make it red maybe. So if you can see here, look how limited that's after becoming. Because if I put that here, that's where, like basically if I put this here right on the beach, this red one, I get rid of that. Between this red here, this red line here, and this yellow line, right, that's the angle, right? But in the distance, it's between this red line and this yellow line. Let's see if I can go in. So as you can see, yeah, that makes a bit more sense. As you can see, this red line here is the beach, and this is the cameraman's eye line. But in the distance, this is still the cameraman's eye line, but the angle has gotten smaller. So I'm just going to get me one of these. So just to show, I'm kind of annotating this one on the fly. So that is angle 1, or that's the apparent, right? Angle 1, and I get another one, and this is, one second now, angle 2, and make the arrow a bit smaller, right? So those two arrows are the same basically, as in the distance from that red line and that yellow line in actuality, and this red line and this yellow line in actuality are the same, but the angle is changing, right? Due to angular size change, everything is shrinking away into the distance. So when my opponent put this yellow line straight through Blackpool and placed it a couple of hundred feet up the mountain, he was completely not understanding. And I tried to explain it to him in the debate, but he wanted to move on. I did say it to him in the debate. I did explain it to him in the debate, but he didn't. It didn't sink in with him what was happening. So this yellow line here, he put it several hundred feet up the mountain. But what would actually happen if I just get another line, right? There's another red line. I'm gonna make that a different color, maybe blue, or what color could be seen? Pink, maybe. That'll do. So what would happen is that in the distance, that if you take this pink line, that bring that right down, and that's what would happen in the distance. That's the angle he would see. It would be, his island would be down there, way down at the bottom, and the mountains would be way bigger. If you know what I'm saying, it's like the mountains here. If this is like 20 foot here, then the mountains would be way, way, way up in the air. His actual placement of his eye line at the base of the mountain. So that's what would happen, right? So as you can see, the angle, right, the angle here changes, right? Because angular size change, so your visual angle has to change. So it's kind of it's a very easy, simple thing, but it's actually very difficult, it seems, for people to get. These two here is the same distance as these two. So that those two arrows, this arrow is far away, this arrow is close, this arrow is far away. That's all it is. They're actually the same. Both those yellow lines are the same distance from this red line. It's just over a distance, that red line and yellow line, right? If we move on further, I'm just going to get another one. I'll just use this one. Just make this one yellow as well. So make this yellow. So if we go back 10 miles, then that yellow will be there. If we go back 20 miles, then that yellow line will be there. Do you know what I mean? If you can imagine what's 20 foot on this roller coaster, what's 20 foot off the ground up on that roller coaster, you know what I mean? You're going to have a situation where there's going to be tiny little bit like that. That'll be your 20 foot. So the further you go back away, the closer that red line and yellow line will appear to become. And eventually they will meet, right? But they won't actually meet. It's like that would be your horizon. So what will happen is it's not that the red line will rise up so much, it's more that the yellow line will come down to meet the red line. the red line won't rise up. The ground doesn't rise up to this whole thing about how the horizon always rises up to your eye line. That's not true. The original statement from 2014-15 was the horizon will always appears to rise up to your eye line. It doesn't actually do that, right? It only appears to do that. But people on our opposition started stating that we were stating that it rose up to our eye level, and then flat earthers being lazy started stating that it rose up to eye level, leaving out the word apparent, because the globers were leaving out the word apparent back then. And now we have a problem where people on our side have been stating it for a long time that the horizon rises up to eye level, and it doesn't. It doesn't do that. But what happens is that as we move further away, so this is the photographer's angle of view from this yellow, let's say from the center line, this will be his center line here in distance. So as an object moves away from him in distance, right, if he's looking directly, whatever point on that object he's looking at, whether it be the top of the object or midway of the object, as the object moves away, this is what will happen, bit by bit by bit, due to the object's angular size change due to the angular size change of the object. So that yellow line will come down, and that'll be at that point at 6 miles away, and that's 8 miles away, 10 miles away, and eventually it'll just be there. The diffraction limit will kick in, where you won't be able to tell the red from the yellow, right? Pretty simple, right? So I think I've explained that pretty well. Hopefully everyone can get that, right? So now I'm going to move on to this. Here is, right, this is from Minecraft. I think it was made in Minecraft, or one of these, I may have been wrong about Minecraft, but it's one of these programs where they mimic the real world. So they make everything across a flat plane. So all perspective is across a flat plane. And this is the center here of the screen, right? And as you can see, the ground here, which would be the green, has not risen up to meet the center, because real perspective in the real world across a horizontal plane, that green won't rise up here to meet my eye line, right? If there's a lot of very good weather and you're at a height in an airplane, it can appear that way. And it can appear that way. But in reality, it's just the angle has gotten so small. But you're still above it, right? So this is the eye line of me here, looking out, right, in the distance. This is the ground underneath me, right? Let's say my eye line is 5'8", right, at my eyes, right? I'm 6 foot tall, so my eye line will be about 5'8", 5'9", something like that. So let's say that's 5'8", 5'9" off the ground, right? So this purple one here, right, in the distance, if that's a couple of miles away, that's where my eye line is now, right? So my eye line height didn't change; it only appeared to change in height. But what it is that due to angular size change, due to vision, my eye line is starting to meet the ground underneath. But it started off above the ground underneath. So the ground underneath is not coming up to meet that eye line. It started off above it. And bit by bit by bit, just like earlier I showed, it'll come down to meet it, and that'll become my horizon, right? So if we look at this here, this right here, right, is this orange line here would be the art perspective, right? So in our perspective, they would have the horizon here, right? It's just an easy way to on a page to get a kind of a basic outlay, and to have some kind of a, you know, in basic amateur art class, they're going to have, or a lot of art classes, they're going to have their horizon right in the very center of the page or the canvas. But in reality, it's not, and real good painters wouldn't have ever put the horizon right in the center, because it's not ever in the center. It's always, if you're standing 6 foot at your eye line, if you're a 6 foot person like me, and your eye line is like 5'8", 5'9", I don't know, whatever, then you're standing looking across a horizontal plane, then your eye line is 5'8", 5'9" off above that horizontal plane. So what's happening here is that this purple line here, right, this is the real the real true perspective place of the horizon, right? That's what a horizon really is, right? In relation to my eye line, right? Um, this orange one is where art would put it, and this yellow one, right, would be where the globe would, or if this is a good distance, this is where the globe's horizon would be, right? If they had a geometric horizon, the yellow line, right? So the orange line is our perspective, right? The yellow line is where it would be on a globe, right? Because it has to keep continually drop, right? On a globe, it can't. Whereas this orange one, or say this purple one here, I just changed the color to red. See if that makes it any bit stand out a bit more. No, that doesn't do it. I'll go back to purple or pink. So this pink or purple one here, this is the actual position of the horizon, right? The yellow is what it would be on a globe because it would have to continually drop down, right, over a distance. And the orange one is the art perspective that's handed to us, right? But art perspective is not real perspective. The yellow one is not what we see in reality. The pink one here, or purple one, right, is what we see in reality. And this is the one that our opposition try to claim. They try to hand us the art perspective and claim that we always say that the horizon always rises to eye level. And unfortunately, a lot of people do say that without giving it any thought. Whereas, as I said earlier, originally it was only appears to rise to eye level, and that is true. That is a true statement. It does appear to rise to eye level, but that's only appears that way. But in reality, it will be below your eye level at a distance because your eye level, if you're looking over, let's say this is water or a flat piece of land, a horizontal piece of land, then you're going to be if your feet are on this ground here, then how can and this here and this all goes along at basically the same elevation. How can your eyes be at the same? How can that ground be at the same height as your eyes? It can't. It will always be below it. So the orange one is not real. It's our perspective. The yellow one is not real. That's what the globe would be if we were on a globe. The pink one is reality, and that's the one that really happens over a horizontal plane. Because you're making, if you can imagine this orange one as your eye line, you're making a horizontal. You're making an optical parallel with if you can see this orange one and this pink one are parallel, this is your actual eye line, and this purple one is the horizon or the ground underneath your feet. So you're making an optical parallel with a horizontal plane. That's what you're doing, right? So one more time, this orange one, this would be where our perspective would put the horizon. That being correct. The yellow one is the globe's actual geometric horizon that doesn't exist. That's where that would be. And the pink purple one here, that's the real horizon that our opposition have been trying to claim for years, right? But all that they've been like, not one of them. I've asked them this, and none of them have ever been able to refute it. I have asked them to prove to me that the horizon that they see, right, or what a horizon dip or drop that they see, right, from a high elevation or any elevation, that dip or drop is more than let's just say the mean sea level to their elevation. That it's more than their elevation, because the higher you go, the dip to the horizon is a little bit more. It depends on if there's good weather. Even if you're in an airplane, if there's good weather, sometimes that can be it can look like it is actually at eye level, but the horizon does. But the thing about it is that not one of them were able to come back to me and prove that the horizon dipped below mean sea level, horizontal mean sea level. Not one of them were able to show that the dip was more than their elevation above horizontal mean sea level, and they can't because that's reality. They need it to be below horizontal mean sea level, which would be the yellow, but they can't. They can never show that because we don't live on a globe. They can only ever show this pink one and try and hand us this orange one. Show us this, hand us this orange one and say that's your horizon, and then try and steal the pink one, which is the real one, for themselves, when the yellow one will be theirs. But that's not reality. The orange one's not reality, yellow one's not reality. The pink one is reality, right? And that's our actual real horizon, right? They have no claim to that, as that's what we're seeing there is over a horizontal plane. They just try and rob it, basically. That's all they've ever tried to do, to try and claim it for themselves, and try and hand us a false strawman horizon. So I'll move on now, 1 second. So now, this is important, right? This here, the red line, right? This is an eye, right? Someone's viewing, right? Someone's eyes. These are 20-story buildings, right? This is 1 mile away. So at 1 mile away, right, the eye line, right, of this person will appear to be looking several stories up the building, right? Because that's perspective. It will appear like they are looking at the, I don't know, the 4th floor, 5th floor, something like that, right? When in reality, their actual eye line is down here, right? Because in reality, let's say this person's of a normal height, then they're only looking a couple of feet up the building. So if I just get another line here, a second, I just change the color to green maybe. So that's their real eye line here. Let's just say put it there so you can see it. The green one, that's their actual eye line, right? But at a distance, the red line will be what appears to be their eye line, right? Because there's an angular size change after happening to the building, right? They've made a distance from it. So if, let's just say we take these 2 buildings, both same height and size, basically, right? Now, if this building here moves this far away, will it still be the same size? No. It'll gradually get smaller, right? And that's what this yellow angle here is showing, that bit by bit by bit, from this observer's point of view, bit by bit by bit, the building will get smaller, right? And it'll appear like they're seeing more of the building. So if this building here gets that size at that far away, then they're not seeing the 4th or 5th floor, they're seeing the 6th or 7th floor. Or it appears that they're seeing the 6th or 7th floor, right? It appears to them. Move it along a bit more, it'll get smaller again, right? So now what floor are they looking at? The 10th or 12th floor. Or that's the floor that appears they're looking at. And we'll move it along again a bit more. And then they're looking at what could be the 15th floor, you know? It's hard to know, right? The building is getting smaller all the time. And we move it along again. Angular size change takes place. The building gets smaller again. So now what floor are they looking at? Maybe the 18th floor. You know, if it's 25 story building. And we move it along again. And buildings that they're getting really small. So now what floor are they looking at? They're looking up towards the top of it. If I take, let me see if I take this. If I can get that red line, right? So if I pull the red line out, try and keep it somewhat straight, they're looking at what appears to be the top of the building. But they're not really. They're actually only looking, they're still only looking down there, where the green line is. It's going to make the green line black, right? They're actually only looking down here, right? But because of angular size change at a distance, it appears that they're seeing higher up the building than they really are. That's all it is. Because the ground is staying the same elevation, right? So that means the base of the building is staying on the ground, right? The ground is not rising up, right? It's just over a distance, over a plane, over a horizontal plane. And what's happening is the building is changing in angular size. So bit by bit by bit, that building, we move it out to here, it's going to go down to there, right? Let's move it in. Whoops. Move it in here a bit. Yeah. So after a distance, it's going to appear like they're looking over the top of it. That's what happens. Angular size change at a distance. This is what it is. This is optical drop. So that 20-story building here that they were at one point looking directly here at, that was their eye line here, right? Let's just put it up here, right? When it went a mile away from them, their eye line appeared to rise on it. And went further away, it rose and rose and rose, and it got to a point where it appeared they were looking over the top of it, over a direct horizontal. So this is what happens when ships are claimed to go over, were claimed to go over the horizon. They were never going over the horizon. They were just having an inferior mirage at the base of it, and they were getting small, so small with angular size change that people were seeing over the top of them. That's all that was happening. There was nothing else happening. So that's all it is, optical drop. Now I'm going to show an actual demonstration of this optical drop to finish off the video. So I'm just going to use this actually. So I just pull it. As you can see, as it moves away, it appears to drop. That's I made sure the table was level. Not that it matters for the demonstration. It's about making a parallel with a horizontal surface, but an optical parallel. But as you can see, it appears to drop. Doesn't really. It only appears that way. So when I move out here, the distance from this black thing here, the bottom of this, to the table, that didn't change. It only appears to shrink. It didn't change. It's still the same as it was when it was in here. It's still the same as that. It's just that it appears to shrink. Angular size, that's all it is. That's all that's happening. A change in angular size and an optical parallel with a horizontal surface. So that's all that's happening. So that's real perspective. That's the real reality we have. Don't accept their art horizon that our opposition try to give us. Don't accept that. That's not the real horizon. They're looking to claim the real horizon for themselves. Well, they can't anyway. They don't even have. They need it to be geometric. But the point is that they've always tried to claim it. It's not. That's the way the horizon should look over a horizontal plane. It shouldn't rise up to your eye. It should appear to over a distance at best, but it should never actually always be at your eye line, because that's an impossibility. You physically can't do that. It's not magic, just physical. It's just optics and the physical world. Okay, thank you.